Hey, we are in Unit 3, Systems of Equations. All right, this is going to be awesome. We're going to be talking about what happens when you see two lines, okay? So we have three different scenarios here. So one thing that could possibly happen when you have two linear functions is those two lines will intersect. And when they intersect, does anybody want to venture to guess what this little guy, this little point is called? Right there. That is called a solution. A solution. Now, a solution will have an x-coordinate and a y-coordinate that goes with it. It looks like it's like maybe like a -1, 0, but we don't know for sure. But that's right there. That's called a solution. So when you have two lines that intersect, they will form what's called a solution. Now, intersecting lines will always have, watch this, they will always have different slopes. All right, they will always have different slopes. Now, those are called consistent and independent lines. All right, consistent and independent lines form a solution. By the way, linear functions only form, at most, one solution. So if you guys ever see like a multiple choice and it says, how many solutions do these form? And it's like one, and then none, and then infinite, and there's like this one that says two. Never choose two. It's never gonna be two for two lines. All right, just so you know. All right, over here. This is kind of hard to understand. You see where it says same line, infinitely many solutions? So I kind of gave you guys a little example. So check this out. I went to Desmos. All right. Do you guys see the red line here? Does anybody know what form that's called right there? It's a certain type of linear function. This is called slope-intercept form. And so there's the slope. That's 5/6. And the y-intercept's at -5/3. So that's called slope-intercept form. Now this form is not slope-intercept form. This is called standard form. We're going to get into that more today. Okay, that's standard form. But what do you notice about the red and the blue lines? Even though the equations don't look the same, what do you notice about them? They're the same line. So what does this mean? This is the scenario that would be called what? Infinitely many solutions. It's the same line. So they're literally touching here and here and here and here and here and here and here. And I keep going, but that would be going forever. Okay. Now, the last scenario, we have parallel lines. And how many solutions do parallel lines have? We got none. Because, by the way, parallel lines, just so you guys know, you could write it here. You could say, hey, they have the same slope. So anytime you have the same slope, they're never going to touch. Okay, so we're going to go over slopes real quick. Won't take long. Just put same slope, parallel lines, no solutions, never going to touch. So let's go over some same slope lines. Ready? So let's check it out. If I said, let's say I had a slope of, let's say 2, and I had a y-intercept at 3. And then I had another line that has the same slope, 2, but its y-intercept's at -5. Are these lines ever going to touch? No, because they have the same. Not because they have different y-intercepts, because they have what? They have the same slope. But as soon as I change that slope to say 1/2, are these lines eventually going to touch? Absolutely. That's called a solution. What's your solution? -5 1/3 and -7 2/3. So that would be your solution for these sets of two lines. All right. So I know not fun, but anyways. So if I said y equals 2, and I put y equals 3, this is where students get confused. Like they're like, how many solutions do they have? Well, none. They don't get confused there. But what's the slope? Whew. Technically, what's the slope of the red and the green? It's totally flat. It's like it's neither positive nor negative. Is there a number that represents neither positive nor negative? That's right. I see it. I see it. Go ahead. Say it. That's right. This is a zero slope. This is a zero slope line. So I want you guys to understand this is called a zero slope line. What did we have before? We had what? What kind of line was this? It was these were both what? Positive, because as from left to right, those are called positive slopes. Okay? And then zero slope is just a nice flat line. We will all be there someday. All right? Hopefully, not soon, but, we'll all be there someday. And then we have this line that's vertical. And you're like, oh my gosh, vertical lines. Can anybody define those slopes? Anybody define those slopes? Anybody? No? How about x equals 5? 55, 5? Negative 2? Hey, anytime you guys see a vertical line, I need you guys to understand these are called undefined. They're undefined slopes. Okay? So do all of these technically have the same slope? Yeah, they all have the same slope. It just happens to be undefined. All right? So would these lines ever touch? No. So once again, what would that answer be for this one? It would be what? No solutions because they're parallel lines. Okay? So, quick little review. Undefined slopes are always vertical. They always mean x equals. Horizontal lines are always y equals. And I'm not just telling you. I am doing what? I am showing you. All right, what I'd like you to do right now is I want you guys to take these two equations right here. They take these two equations and write them carefully down in your journal. We're going to be talking about the difference in these two equations. It says solve each system of equations by graphing. So we will definitely solve them by graphing. But before we solve them by graphing, I want you to write these down in your journal. So the first one is x minus 2y equals 0. And the other one is y equals 2x minus 3. So write those down. All right, above the blue one, I want you guys to write ax plus by equals c, because this is called standard form. And over here, I want you to write y equals mx plus b. So once again, I'm going to write, we have something called standard form. And we're going to go over standard form, and we're going to review slope-intercept form. Now, this is stuff that you should already know, but, you know, it's probably been a while since you've had Algebra 1, so we're just going to go over it just to make sure that you understand. So slope-intercept form is y equals mx plus b, and standard form is in this form, ax plus by equals c. Now, in standard form, there's things that you need to understand. Your a value will always be greater than or equal to 0, so it's never going to be a negative. You'll never have a negative. A, b, and c will always be integers. So integers are numbers that aren't decimals, okay? You're not going to have like halves or thirds or anything. They will just always be positive or negative numbers. The only one that can't be negative is the a value, okay? And then this is the part where students sometimes get confused. We'll talk about this. The greatest common factor between a, b, and c, I'm going to put between. The greatest common factor, which is the GCF, the greatest common factor between a, b, and c is the number 1. I'll try to do a better job of drawing the number 1. I'll put equals 1. Between a and b, c equals 1. Now, if you ever forget what GCF is, I mean, I don't know. I'm just going to try something real quick. Let me delete some things real quick here. You don't need to know that. Let's just Google it. You know what? Let's just put GFC. Sorry. See what happens. I'm just... Oh, wait. My bad. GCF, greatest common factor. My apologies. There we go. Hey, look! Make sure, did I write it down? Did I write it down correctly? Oh, my bad. I got to put GCF, not GFC. Greatest common factor. Oops. Yes, the greatest common factor. My apologies. There we go. But you just Google it. See, greatest common factor. You know, GCF. There you go. All right, so you know I'm not making this stuff up. So right now we have slope-intercept form and we have standard form. Each of them has its own special qualities. All right. So let's go with the easiest one. What is our m value represent? It represents the slope. And what is our slope of the red function? What would you guys say? I can still hear you. I'm teaching a class right now. 2. Yeah, 2. Good. So we have slope of 2. Now, what does that mean? That means our slope is 2 over 1. Remember, we are dealing with what's called the change in y over the change in x. This is a little triangle. It's called delta, and delta means change in. So whenever you see me put delta y or delta x, that means change in y over change in x. And the b value, what does that represent? That represents the y-intercept. And what is our y-intercept at? -3. Now the ordered pair that goes with that y-intercept would be 0, -3. Okay. So what I'd like you guys to do, this is the easy part of the graph. This is an easy one. What I want us to do is I want you to go to your paper, which is right here. Okay. And I want you to graph right here at -3, put a point on your paper. That's your y-intercept, 0, -3. And then we're going to apply a slope of 2. So from the y-intercept, I'm going to go up 2 units and over 1. So up 2 units over 1, up 2 units over 1, up 2 units over 1. And then you're going to do your best just to draw a nice line that connects all those points. Now, this is in standard form, so it is not in slope-intercept form. So there's a couple ways we can handle this. One way is actually to change it to slope-intercept. All right, and I'll show you guys a shortcut. That's horrible. I could do a better job. I'll do it. That's a little better. Okay, so what we're going to do is we're going to solve for y. All right, we're going to solve for y. So the first thing I'm going to do is I'm going to get all the y's by themselves. I'm going to take away an x from this side, take away an x from this side. So that's one way you could have done this, okay? And if you would have done that, you're left with -2y equals -x. So that's one way to do it. Another way to do it is, if you wanted to, you could technically add 2y to this side and add 2y to this side. Now, what's the benefit in this particular case of adding 2y to both sides? I have an x on the left, and what do I have on the right? 2y. And everything's what? Everything's nice and positive. So that zeroes out. We add these together. 0 plus 2y is just 2y. And then we just divide both sides by 2. And you get y equals x over 2. But in slope-intercept form, that's written as a half of an x when you solve for y. So what is a half of an x? That's the same as what? A number being divided by 2 is the same as a half. So what's my slope? And what's my y-intercept? Well, my slope is 1 over 2. And I don't see a constant being added to the end of it, so my y-intercept is at a 0. So all I'm going to do is I'm going to go up here. Hopefully you guys have the process for solving for y. You're going to put your y-intercept at 0, and you're going to go up 1 and over 2, and up 1 and over 2. There's your slope, up 1 over 2. I can also go down 1, but I would have to go over 2 to the left, because this is a positive slope. Well, I thought down's negative. Well, yeah, if I go down negative, then I got to go over 2 left negative, and a negative divided by a negative is a positive. So there are my two lines. There we go. Does anybody see where those two lines intersect? Right there. So what do we call that point? Once again, we call it a solution. So what is the solution of these two lines? The solution is at a 2 and a 1. A 2 and a 1. All right? So this is what I'd like you guys to do right now. This solution's at a 2 and a 1. Okay? So check this out. What was our first equation? Our first equation was 2x minus, no wait, is it x minus 2y? My apologies. Was it x minus 2y equals 0? And the other one was what? Y equals 2x minus 3. What I'd like you guys to do is I'd like you guys to plug in our solution. What was our solution? 2 and a 1. What was our solution again? Plug in a 1 for a y. And what number for x? 2. Let's see what happens. 2 minus 2 times 1 is 0. And is 1 equal to 4 minus 3? 1 equals what? 4 minus 3. So how can you check your answers? Just plug them back in and see if they work. Because remember, what did we get as our solution? We got an x value of 2 and we got a y value of 1 for our ordered pairs. All right, so what we're going to be doing right now, we're going to go over here to this problem right here. You guys see it says x plus 2y equals 4. So I'm going to put x plus 2y equals 4, and in a different color, I'm going to put 2x minus 3y equals 1. Now, these are both in standard form, so could you guys make sure you put ax plus by equals c over this one, and put ax plus by equals c. All right, we're going to show you guys some shortcuts here, okay, to help you guys be able to find slope, y-intercept, x-intercept, all that good stuff. So here we go. Check this out. We got to identify a, we have to be able to identify b, and we're going to identify c. And over here, we're going to identify the a value, the b value, and the c value. We're going to show you the importance of standard form, okay? So, can you guys see right here, even though you can't see it, the number that's in front of it, technically you have what? You have a 1x. So our a value is a 1. Our b value, you can clearly see, is a 2, and our c value is a 4. Over here, what do you guys see as the a value? What would you say? 2, correct. Now this is where it gets tricky. What about the b value? -3, very good. So you got to pay attention to that negative sign, okay? And our c value is just at a 1. All right. Now, I'm going to talk about 3 different things. Ready? We're going to talk about slope, which is what? Which is your m value in slope-intercept form. We're going to talk about how would you find the x-intercept, and the x-intercept is when the y value is equal to 0. And then we're going to talk about the y-intercept, and the y-intercept is when the x value is equal to 0. So we're going to find the slope, the x-intercept, and the y-intercept just using standard form, just using these a, b, and c's. So make some columns here, all right, if you want to, or rows, whatever you want to do. We're organizing. We're going to find the slope, which is the m value. We're going to find the x-intercept, which is the place on the graph where the line hits the x-axis where y is 0. And we're going to find the y-intercept where the x value is 0, and then wherever hits the y-axis on that line. So write those down real quick. All right, so here's kind of a cool formula. The slope, if it's in standard form, will always be the negative a value over the b value. That's what the slope will always be. So over here, I'm still going to put slope will still be negative a over b. The x-intercept will always be the c value divided by the a value. And the y-intercept will always be the c value divided by the capital B. So this is just a formula. If you know your a, b, and c, then you can find the x-intercept and you can find the y-intercept without having to do a whole bunch of complicated math if you have these little formulas. Okay? So we'll show you how to use them. Does everybody see m equals negative a over b? So I'm going to put, ready? I'm going to put negative. It's not a over b, it's what? Negative a over b. What's my a value? 1. What's my b value? 2. What's my slope of the blue line? Negative what? Negative 1 over 2. All right. Let's see if we can find our x-intercept. What's my c value? Boom. Sorry, C4. Boom. Just kidding. All right. So what's my a value? 1. What's 4 divided by 1? That means my x-intercept is at what? 4, 0. All right. And what about my y-intercept? It says what? C over what? C over b. What's my c value? What's my b value? 4 divided by 2 is 2. So what am I going to plot on my graph? 4, 0, and a what? 0, 2. And what should we have a slope of? Negative 1 over 2. Huh. By the way, could I take this information and write it in slope-intercept form? Sure. I could put it in y equals mx plus b. It's y equals negative 1/2 x plus my y-intercept, which is at a 2. So here we go. We're going to go up here, right here. What did I say my y-intercept was at? A 0 and a what? 0 and a 2. What was my x-intercept at? 4 and 0. What did I say my slope was? Down 1 over 2. Down 1 over 2. Now, I'm going to go up 1 over 2. Here we go. Go ahead and draw that on your graph. Draw it down nice and neat. While you guys are doing that, I'm going to show you in Desmos that what I just did was true. So you see where it says x plus 2y equals 4? There's my slope-intercept, okay? So x plus 2y equals 4. I'm going to write it down right here, okay? X plus 2y equals 4. Y equals negative 1 divided by 2, x plus 2. What do you guys notice about, I'll even change color so you're not think I'm not trying to trick you or anything. What do you guys see about these two forms? They're different forms, but they graph the what? They graph the same line. Okay? What do we call this form? Standard form. What do we call this form? Slope-intercept form. So another way I like to call this is the cover-up method. Check this out. You guys see the hand? Oh, I'm going to take a picture of this. Everybody see the hand right here? Watch what happens. If I want to find my x-intercept, I cover up my y's. What do you guys see? X equals what? Which is right there. If I cover this up, what do you guys see? 2y equals 4. Well, what's 4 divided by 2? 2. So you can always use the cover-up method to solve. What does that mean? That basically means, everybody, is that I'm making y equal to 0 to solve for my x-intercept, and I'm making x equal to 0 to solve for my y-intercept. All right? What does it mean for your formulas? Very easy formulas, right? Will these formulas ever change that I gave you right here? So if you're wondering what formulas I'm talking about, I'll go ahead and put a green box. These are the green boxes that you need to know. Here we go. Put it in a green box. That's your box for your what? Slope. This is the box for your x-intercept. This is the box for your y-intercept. It can even solve more complicated ones. So we're going to go ahead and go to red and see if you guys can figure out the red. M equals. So here's what I want you guys to do. Go and pause the video, and I want you guys to see if you can find, here's my A, here's my B, here's my C. See if you can find the x-intercept, the y-intercept, and the slope for the red graph, okay? So go ahead and try that right now. All right, here we go. Let's see if you guys got it. Negative A over B. So we'll put negative, what'd you guys have for your A value? 2 over, what's my B value? Negative 3. And what is negative 2 divided by negative 3? Positive 2/3. So if I was going to write it in slope-intercept form, if I was going to write it in y equals mx plus b, I would put y equals 2/3 x. And then all I got to do is what? Find my y-intercept, which we will find shortly. Okay, x-intercept. C over A. What's our C value? 1. So put 1 over, what's our A value? 2. So my x-intercept is going to be at 0.5 comma 0. 0.5 comma 0. All right, y-intercept. C over B, right? 1 over negative 3, that's okay. So this would be at 0 comma negative 1/3, or negative 1 over 3. I know I didn't do a very good job of that fraction. I'll make it nice and neat, hopefully. Negative 1 over 3. Okay? So what's our y-intercept? Our y-intercept's at negative 1/3, so if I wanted to write it in slope-intercept form, I'd put minus 1/3. This is our answer in slope-intercept form. So here we go. Let's go and plot some points that we possibly can. Let's go up to your graph. Could you guys put a 0.5 comma 0 right there? Sure, right? It's kind of hard though, right? But from there, could you go up 2 and over 3 if you wanted to? From this point, would it be easy to do up 2 over 3? 1, 2, 1, 2, 3. That's fairly accurate, wouldn't you guys say? Wouldn't that be fairly accurate? Now, what was the hard point to plot? What, negative 1/3? So I'm just going to put it right about there. If you guys connect these dots, if you connect the dots that you can actually connect, can you guys see where the solution could possibly be? Right there. Now, I'm going to check it. Ready? I'm going to check to see if this solution actually works with the red graph. What is my ordered pair right there? What's my solution at? What would you guys say? Over 2 and up 1. Let's see if this works. 2 times 2 is 4. Is 4 minus 3 1? So it does work. And what do we call this? We call this a solution. All right? All right, so guys, this is really, 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 really important. I want you guys to understand in your journal, make sure you know to find the slope in standard form, it's negative a over b. To find the x-intercept, it's always what? C over a. And to find the y-intercept, it's always c over b. So what we're going to do right now is we're going to do one little last problem. This is the last thing we're going to do for the day, and you guys are done, okay? No homework or anything like that unless you have stuff that you got to do that you didn't get done earlier. So we're going to go ahead. We're going to create a problem. I'm going to call it, I'm going to go 15x minus 18y equals 30. And this is in ax plus by equals c form. Now technically this is not in standard form. Wait a second. Are all these integers? Yes. Is the a value positive or greater than or equal to 0? Yes. But is there a greatest common factor that you could divide into a 15, an 18, and a 30? What could we divide everything by to simplify it? Divide everything by a 3. So guys, this is now in standard form. 5x minus 6y equals 10. What we're going to do right now is I want to see you guys identify your a, identify your b, identify your c, and I want you guys to find the slope. Remember, your slope is negative a over b. I want you guys to find your x-intercept. And remember, your x-intercept is the c value divided by the a value. And your x-intercept is always when y is 0. And then I want you guys to find your y-intercept, which is your c value divided by your b value, and it'll always be 0, comma, y. ax plus by equals c. All right, so what did you guys get for the a value? 5. Very good. What did you get for the b? Negative 6. And for c? 10. Okay, so my a value is 5, my c value is 10, my b value is negative 6. So negative a over b. So we're going to put negative, what number? 5 over negative 6. What's my slope? 5 over what? 5 over 6. C over a. What's my c value? 10. A value? 5. 10 divided by 5 is? X-intercept is 2, 0. C over b. 10 over negative 6, right? All right. That reduces to negative 5/3 because you can both have them. All right. So my y-intercept is at what? 0, negative 5/3. So what would be my answer in slope-intercept form? The answer in slope-intercept form is 5 over 6x minus 5/3. That's my answer in slope-intercept form. So what did we start with? 5x minus 6y equals 10. What did we finish with in slope-intercept form? Y equals 5, 6x minus 5/3. What can I do to make sure I did everything right? Type it in what? Type it into Desmos. Here we go. Ready? 5x minus 6y equals 10. And what do we get as our final answer? What do you get? 5 divided by 6, right? X minus 5 divided by 3. What do you guys notice? It's the same line. What do we call this form? Standard form. What do we call this form? Slope-intercept. Hope that was helpful.